So here we go with example 2, and we've now switched to a velocity time graph context. As usual, let's go through, read the question and pick out the key things. The figure shows a velocity time graph illustrating the motion of a cyclist again, moving along a straight road again for a period of 12 seconds. For the first 8 seconds, she moves with constant speed of 6 meters per second. She then decelerates at a constant rate, stopping after a further 4 seconds. So stopping at a constant rate, decelerates. Find the displacement from the starting point of the cyclist after this 12-second period. Okay, so factual knowledge that we're going to need. It's the area under a velocity time graph is equal to the displacement. And that makes sense, because if you think about this here, first bit, it's a rectangle, and we know that the velocity, if you're travelling at 5 meters per second for 10 seconds, you multiply the two to get 50, and that will give you the total distance travelled at 10 meters per second for 5 seconds, or 5 meters per second for 10 seconds. It doesn't really matter which way round you do it. So the key fact is it's the area is the velocity, is the displacement. And similarly then, when you're decelerating, it will be the area of the triangle. Okay, but we should be better than that if we think about the shapes we know the area of from GCSE maths. So the second bit of factual knowledge that we're going to need here is area of a trapezium is equal to A plus B, the sum of the parallel sides, times the perpendicular distance between them over 2. The height is the perpendicular distance between them. It just depends on how you want to write that. A plus B times h over 2. Okay, so this part A, displacement, is equal to area under the graph, which is A plus B times h over 2. So A and B are our parallel sides, and h is the distance between the two. So we get A as 8 plus 12 as the lengths of the parallel sides, times the distance between them, which is 6 over 2. 20 times 3 equals 60. Go back and check the units. The speeds were meters per second, the times were seconds, so the displacement must be in meters. Part B. The rate at which the cyclist decelerates. All right? So acceleration is the rate at which the velocity changes. So that's change in velocity over time taken. Another way of thinking of that, and I didn't emphasise this on the last example, but that's like the gradient. So So that's the same as the gradient of the line. So if we come back, the gradient, well, we can use what we would use at GCSE, rise over step. So we're going across from 8 to 12, which is 4, and then we're going down from 6 to 0, which is -6. So we will have acceleration is equal to -6, the change in velocity, over 4, which is -3/2 meters per second squared, equals -1.5 if you'd rather be in decimals. Okay, but if we read the question, it actually says the deceleration. So that was the acceleration. Deceleration effect is the negative of acceleration. It's in the opposite direction. So deceleration is equal to 1.5 meters per second squared. Deceleration is a negative of acceleration. And if you just miss those little bits of detail off an exam, it's going to cost you a mark. Okay.